Well, hello people. We're going to set a record as to how fast we can record a lesson, I think, today. This is lesson 34, and it's pretty easy, although the concept is a little bit difficult, but it's not very long to talk about. Lesson 34 is learning to plot decimal numbers on the number line, and we've plotted numbers on the number line before, but plotting decimal numbers can be just a little bit more delicate, I guess, as I could say. If we were to take the distance between 0 and 1 on a number line and divide that into 10 equal parts, we would be dividing that into tenths. We would say each part is a tenth. We would refer to it as 1/10, 2/10, 3/10, 4/10, etc. And above I've written the decimal equivalent, which is 0.1, 0.2, 0.3, 0.4, 0.5, etc. These are all between 0 and 1. Now, either way, 1/10 or 0.1, they're representing the same thing. And that's an interesting thing because sometimes we don't realize that there's a whole lot of ways to name a number. We can name it in words, we can name it as a fraction, we can name it as a decimal. There's just a whole lot of ways we can name a number. On a number line, we can find a decimal by finding the increment, or the number of parts that corresponds to that decimal. In other words, if we were looking for 7/10, we would go back to the number line and we'd look for, we'd say, okay, there's 1, 2, 3, 4, 5, 6, 8, 9, there's 10 spaces on here. If we go 1, 2, 3, 4, 5, 6, 7 spaces over, that's 7 of 10. And therefore it is 7/10. Okay, going on to page 2. We know there are 10 millimeters in a centimeters. So if we're going to plot a millimeter on a line, we just look to see increments of 1/10 on the line. So here is another line, and yes, I probably think it would be a good idea for you to put it in your notes. This is enlarged so that you can see. And what I've done, of course, is I have taken the distance between 0 centimeters and 1 centimeter. Now, obviously that is really, really, really bigger than it would be, millimeters included. But I wanted to make a point. 0, 1, 1 centimeter. There are 10 millimeters between 0 and 1 centimeter. So this is 1 millimeter, 2, 3, 4, 5, 6, 7, 8, 9, and 10 millimeters makes 1 centimeter. Now, if I wanted to be a little bit more creative and I wanted to mark where it was 1.5 millimeters. Okay. Well, this is 1 millimeter and this is 2 millimeters. So 1.5 to me would be like right in between. Okay, so then this becomes 1.5 millimeters. And you could go down here and this is 9 millimeters here, right? You could actually mark 9.5 millimeters. So that's kind of an interesting thing. The more you expand the line, the more things you can fit on it. And as is truly said, there are an endless number of numbers on a line. So I could go smaller and smaller and smaller and smaller and smaller. I could be 10 hundred thousandths on this line if I wanted to stretch it out enough. Okay, when you plot tenths on a number line, oh, that's really too big, so I guess I better take it back so that we could actually read it. Okay, so to plot tenths on a number line, we simply have to have the distance between each number or integer divided into 10 parts. So up here we plotted 9.5 millimeters. Okay. Now down here, down at the bottom, we are going to add a number line. It's really kind of rad. It's got a lot of divisions on it. Okay. So I'm gonna move it up. I'm gonna focus it in. Okay. Have an idea as to how to set up a number line that allows you to graph numbers that are smaller. Will be helpful for you for future references. If you notice, this is just between 3 and 4. Okay? Between 3 and 4. And between 3 and 4, I have set up 0.1, 0.2, which is of course 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. And then this of course is 10/10, and that puts us at 4. Now between 3.0 and 3.1, I've put in 10 markers. Between 0.1, 0.2, I've put in 10. Between 0.2, 0.3. So if you were to count from here to here, there are 100 marks. Okay, so now this shows you exactly where things are at on this number line. If I went to, this is 3.1, and if I went right in the middle, this would be 3.15. This is 3.4. If I go not quite to the middle, one before the half, this is 3.44. If I want 3.69, I go to 3.6 and almost to 0.7, but not quite, so it's 3.69. 3.91, 4, I'm over here to 4, 4.11, 4.23. Kind of a cool way to do it. And if you have the time, or you take the time to set up a number line for yourself, you will never ever go wrong as to what order numbers need to be put in on a number line. Anyway, that's what I have to say for today. I hope you had a fun time writing this down, and I'll talk to you later. Bye.